projects. In this video, we are going to explain about the project title Classification of Electromyographic Hand Gesture Signals using Two-Step Machine Learning Approach. Before diving into the execution, let me give you an overview of the project. Electrical signals produced by the contraction of muscles in the bones are known as electromyographic EMG signals. Electrodes are usually applied to the skin above the muscles of interest in order to measure these impulses. The timing and force of contractions in the muscles, as well as other important details about muscle activity, are all revealed by EMG signals. EMG signals can be used in the context of hand gesture classification to identify and categorize various muscle activity patterns connected to particular hand movements or gestures. The project uses electromyographic data to classify various hand movements such as hand at rest, hand clenched in a fist, wrist flexing, and more. The project seeks to predict the matching hand motions by supplying EMG signal data in a CSV file. Traditional approaches to EMG signal classification for hand movements usually include signal processing methods, including feature extraction and filtering. These techniques, however, have limitations, including noise sensitivity, the need for manual feature selection, and trouble with non-linear feature gesture connections. To overcome these limitations, the proposed system combines windowing, CNN, convolutional neural network, FNN, feed-forward neural network, KNN, K nearest neighbor, decision trees, and random forest algorithms for accurate classification of EMG hand gesture signals, pivotal for prosthetics and human-computer interaction. In this project, we have integrated Flask for building the web application to deploy our project. Flask, a lightweight Python web framework, is integrated to provide a user-friendly interface for this project. It manages user authentication and enables CSV file uploads for analysis using SQLite 3 as the database. With Flask handling routing, the project seamlessly connects user interface actions to backend processing and prediction. This integration makes the project accessible via a web browser, enhancing usability and accessibility. To implement this project, we need software and hardware requirements. Software requirements of the project are: application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Algorithms used. These are the algorithms built in the project. We have built all these algorithms to compare the performance with different evaluation metrics like accuracy, precision, recall, and FN score. And here the KNN, that is K nearest neighbor, outperformed the other algorithms, and that is the reason we have deployed it in the front end. Now let us execute the project. To execute this project, first we need to open the code folder which contains the project source code files. So here, this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here, this is the EMG data. Let us open this. So here, these are the parameters: time, channel 1, channel 2, channel 3, channel 4, 5, 6, 7, 8. And here these are the class and label column. So these channel 1 to 8 columns represent different channels or sensors used to capture data. Each channel corresponds to a specific aspect of the recorded signal, such as different electrodes or sensors in EMG, electromyographic signals. These channels capture the raw data or features of the signals. And this data is used to train the models. Now close this data. This is the model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. And here, this is the test cases file, which we will use during the execution. Now, we need to copy the path of the code folder from the address bar of the file explorer. So here, I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flash framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link provided by the Flash framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flash framework. If we are new users, we need to register first. So click on login. Since I have already registered, so here we need to enter the username and the password, which are static, and then click on login button. We have logged in successfully and we are redirected to the prediction page. So here we need to upload the CSV file of EMG, electromyographic hand gesture signals. And after uploading a CSV file, the application will predict different hand gestures from the electromyographic hand gesture signals. Now click on choose file to select the CSV file. So here I'm selecting the test cases. Now click on open. So here we can see that the test cases is loaded. Now click on upload button. So here we can see the prediction result. So these are the electromyographic hand gesture signals, and here we can see the predicted label has wrist flexicon. So here the data consists of electromyographic signals, EMG hand gesture signals, and their predicted labels. Each signal is represented by numerical features with the model predicting the corresponding hand gesture. So here we can see the different predicted labels, which are wrist flexicon, hand clenched in a fist, and hand at rest. So these are the different hand gestures from the EMG hand gesture signals. So these are the signals and these are the predicted labels. So the goal is to create a reliable system for accurately classifying hand gestures from EMG signals with applications in prosthetics control, human computer interactions, and rehabilitation. Now click on sign out link here. By accurately classifying EMG signals associated with hand gestures, the project contributes to improving prosthetic control systems. This can benefit individuals with limb loss or limb impairment by enabling more precise and intuitive control of prosthetic devices. And also, it is crucial for developing interfaces for human machine interaction. This project's approach can lead to the creation of more responsive and efficient systems for controlling devices through gestures.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.